Hello everybody, welcome to the third R Help session video. I would like to preface this by saying a few things. So first of all, this homework may seem a bit more difficult than the previous two homeworks, but I want you to know you can do it. It involves making lots of tables and interpreting those tables. And I know it's going to seem very difficult at first, but I encourage each and every one of you to dive into it and experiment switching your X and Y and other things like that to see what the information you would be getting in that scenario is. Each and every one of you can do it, so I encourage you to go into it open-minded. Also, I'd like to say two very important things. First of all, my stat lab does not have any leniency in regard to decimal places, so use however many it says. Second, the third homework involves some copying and pasting from my stat lab instructor instructions. So you need to take out periods or anything else that appears red on the R script. You'll know because it will show an error, and then you'll have to take out whatever is causing the error. You'll understand once you start doing the homework. Okay, so first you need to import your data. I already have imported my data. I don't want to do it again because I don't want to waste any time. So I'll jump right into it. First, I'm going to start with making a simple table. By the way, this is real data that I'm using. I found it on the internet. It's from Brazil. So I'm going to make a simple table of patient data by gender. So when you do this, it's quite obvious. It shows females, this amount, males, this amount. So now I'll ramp it up 1 degree of complexity. I'll use patient data by gender again, and then I'll also add another parameter. I'll add diabetes. Okay, so this table is going to give us how many females have diabetes and how many males have diabetes and how many do not. Typically, if you see a 0 or 1, 1 means presence of the trait and 0 means lack of the trait. So as you can see, females represent this area I've highlighted, males represent this area. So an example question would ask something like, what percentage of females have diabetes in the data set? So what you would do is take how many have it divided by total number. So I'll really quickly go over how to put that into R. So this would be the percentage of females, and then you would do the same thing for males. 2,337 divided by the total of 36,350 and 2,337. So now I'll go one step up in regard to complexity, and I'll make a table with a third parameter. So I'll again do gender and diabetes, but I'll also add hypertension. So what it's going to do is make two different tables. Each table is going to have gender and the presence or absence of diabetes, but then they're separated by 1 and 0 for hypertension. So this table with gender and diabetes again is going to be for people with hypertension indicated by the equals 1 above it, and this table with equals 0 above it is going to be gender and presence or absence of diabetes for people without hypertension. So the most important thing to keep in mind is you need to know what the tables are saying. You will have to make all three of these kinds of tables. So feel free to pause the video or practice, like I said, using the data set smokers or bike, which is actually on the homework, to see what kinds of questions you could answer with each of those data tables. So here's another example from real data I found, just demonstrating how to use the different type of data. So for example, I could do kidney data by blood pressure. These are blood pressures, and these are how many people have each level of blood pressure. Or I could do it in this manner. I could separate age and blood pressure. So this one looks a bit more complicated, but it's essentially the same thing. On this side, by the way, whichever whichever category you put first will be on left and right side, and then on the top and bottom will be, or on the top rather, would be the second one you put in. So this is how many people of each age have each blood pressure. So no one of 2 years of age has any of these, but once you get up to 11, you have one person with a blood pressure of 80. So that's just another example of what these tables mean. So now I'll go into making a vector with your own data and what that would mean. So I'm just going to make up some example data of people in 4 different grade levels. You will have to do something like this on your homework, but it will be different data. I'm just making this up for the purpose of example. Okay, I'm setting a level and frequency. These are arbitrary vectors. I'm just using these for the explanation. I believe it tells you to make them the same thing on the homework. Okay, so what I'm saying is to organize these numbers by level, and I'm assigning them in their respective places. So I'm making a bar plot where I'm putting the level on the x-axis and then the frequencies on the y-axis. So you can recreate this. These will be in the instructions on MyStatLab, so you don't need to worry too much about the commands. I'm just demonstrating how to put them in correctly and how to use them. So make sure you use the same format with whatever numbers it gives you. You can also make a pie chart, as I'll show you. Again, these instructions are in MyStatLab, but I'm just demonstrating how to use it correctly for basic troubleshooting issues. Okay, so like I said, this is how to make a pie chart. It's automatically colored and it's separating it by each division I gave it, which would be level, because that's the name. I could change this, change level to something else, and then put whatever that name is here. It's arbitrary, but the reason why I made it level is because it helps explain what I'm putting in. So the next thing I'd like to go over is simply if you say in row and then your data frame, it counts how many rows there are. You can do the same with in col for in column to see how many columns there are. And you might wonder why use this when you could just click on the data frame after pressing view and count all the way down. Well, the reason why is because for some data sets that you might encounter in the real world, you're going to have way too many to count, and it will lag if you try to scroll down all the way. So for example, in my patient data set, there are 110,527 rows, so using this is easier than scrolling down and counting. Okay, so the next is making a table, but we're going to do something different with it. So we're making a vector called table1, and inside the vector we're going to make a table. You'll see why shortly. Okay, so we made this table earlier at the beginning, but now we're putting it in a vector. The reason why is because we're going to make a prop.table, which is a table of proportions. Okay. So now we've made the prop.table. So just to demonstrate, since we made the vector, we can type in table1 and it will give the table for which we made the vector. Or we can type prop.table and it will give the proportions. So let me explain this 2 right here. If you put in a 2 here, it's going to make it where the columns sum to 1. And if we put a 1 there, it's going to make the rows sum to 1. So this is a very important distinction whether 1 or 2 here. Let's think of it in regard to an example. So we have 2 here. Let's run the prop table. So like I said, 2 makes the column sum to 1. So an example of this would be, remember 0 is without diabetes, 1 is with diabetes. So what, out of the people without diabetes, what percentage are male? 35%. And out of the females, if we change it to 1, we could ask a question such as, out of the females, what percentage do not have diabetes? 92%. What percentage have diabetes? 7.8%. And we can get these by changing this to 1 because the rows sum. And just, if we want to check, we could do what I showed at the beginning. This calculation returns the same thing, about 7.8%. And remember, these are proportions, so multiply this by 100, or any of these by 100 if you want to see the percentage. Okay, so keep in mind the 1 versus 2, because it changes what's adding. 2, 1. Also, another way to create the prop table is by doing this. Prop.table, open parentheses, table, and then how we would normally make the table. Okay, so as you can see, this returns the same as doing this and then printing these. The reason why I did it in this manner is because it's easier to reproduce. In my opinion, when you type prop.table before it, there's more room for error. But it is one line instead of a few, so it's more efficient. You can do it in whichever way you prefer. They're both very valid, or equally valid, rather. Okay, so again, I just cannot emphasize enough how important putting 1 or 2 there, depending on what you're looking for, is. Think of whether you want the row or the column. It's to add up to 1. Okay, so next, bar plot. I'll make a bar plot with the prop table I already made. Prop.table1. Yes, I'm going to name it. Well, I'm going to add a color, rainbow 2. This just creates a distinction between the colors, and then legend equals true. It puts a legend. So in case you're curious, I'll save this line. You take out legend equals true. It works. There's no legend like there was, and you take out color equals rainbow 2. It's going to default to this, which is fine. So technically you could have legend equals true, and it would tell you. The reason why I put rainbow is because when you have a more complicated one, you can change it to a rainbow higher number to create different colors, because the grayscale ones get quite mundane and it's easy to get them confused. So anyway, that's just for your information. Here's the bar plot. So as you can see, they're different sizes and they're representing how many males and females have diabetes. But let's change this back to 2 and show what it would look like then. Okay, so now we're doing we're putting 2 here. So when we put 2 there, the columns add up to 1. So we're fundamentally changing this. This is the proportion. So as you can see, and this question would answer in this scenario, what percentage of the people without diabetes are females and what percentage of the people with diabetes are females or male. So the reason why they're both equal to 1 is we're saying out of 100%. We're not saying what percentage have diabetes and what percentage don't. It's important to keep in mind which question you are answering. So let me change it back real quick. So if we do have it like this, you have to understand 1 will be a lot smaller because not as many people have diabetes in the data set. Very few of them do. This number, or these 2 numbers compared to these, so that's why it's a lot smaller. So on your homework, you'll have to discern what's actually being asked. So the last thing I'll go over is the mosaic plot. I'll make a mosaic plot for table 1, which is one of the tables I made previously. And a mosaic plot is showing proportionally how many people fall into each category. So this is for table 1, and there are a lot more females than males in the data set, almost double. So let's make a mosaic plot for prop table 1 and also set the color to rainbow 2. So as you can see, when we set it for the prop dot table 1, which is the table of proportions I made, they're divided 50-50. So this is a better representation if we're trying to find percentages of the two genders represented in the table. Doing it this way shows percentage of the population, but as there are more females than males in the data set, the side of the mosaic plot for females is almost doubly as big as the one for males. So I hope that clarifies a few things. Like I said, you really just need to practice a lot of this yourselves to find out which way helps you. I remember when I was doing this, what I did was experiment and switch the X and Y, or the order of the things which I was putting in, and that helped me understand it a lot better just through excessive practice of that.